Hey guys, welcome back. In this video, we will be discussing about a very important rule for differentiation, which is called the chain rule. We use this rule when we need to differentiate a function which is a composite function. Now let's say we have a function h of x which is equal to f of g of x, and this is a composite function. Why? Because the input parameter of this function f is itself a function. Let's say if we call this as the inner function, and this function will be our outer function. So the outer function is f of g of x and the inner function is g of x, and g of x function is dependent on the parameter x. So this is a composite function, and chain rule comes into the picture when we need to differentiate a composite function. So let us write the chain rule. What exactly is the chain rule? The chain rule is for the differentiation of composite function. And here we need to differentiate h of x. So that would be d by dx of h of x. Now, in order to achieve this, first we need to differentiate this composite function with respect to the inner function. Then multiplied by differentiation of the inner function, that is g of x, with respect to the parameter on which it is defined, which is x here. So in this case, it is d by dx. So we will differentiate this g of x with respect to x, and this defines the chain rule. So it might be looking a little tricky as for now, but this is actually very easy to memorize. In order to remember this, first we need to differentiate this whole composite function with respect to the inner function, that is g of x here. And after that, it is multiplied by the differentiation of the inner function with respect to the parameter on which it is defined, which could be anything. And in here, the inner function is defined on parameter x, and hence we differentiate with respect to x. Hence we write it as d by dx of g of x, and this is the chain rule. So this is the very important rule when we talk about derivatives. This will really help you in solving a wide variety of problems when we are dealing with derivatives. So this is the chain rule. Now we will take some examples to make this concept more clear. So let's start with our first example. So the question is to find dy by dx where y is equal to sine x whole cube. This dy by dx is nothing but d by dx of a function y. So this is the other way of saying d by dx of y as dy by dx. So these are equivalent, and they both mean differentiation of y with respect to x. And here y is equal to sine x whole cube, right? Now as you can see it from here, this is a composite function. So let's define our inner function here. The inner function is g of x is equal to sine x, and the outer function is f of x is equal to x cube. So when we replace x with gx in f of x, then in the outer function x cube, so it will become sine x whole cube. So when we take x in place of gx in the outer function, right, we get x cube, and hence we can write f of g of x as sine x whole cube. Now we will apply the chain rule here. Okay, so how do we write this as? We'll write it as dy by dx will be differentiation of the composite function with respect to the inner function, which is sine x here. So that is d by d sine x. D sine x means differentiating the above function with respect to sine x. So since it is the inner function, and then we multiply it with the differentiation of the inner function with respect to the parameter this inner function is defined, that is x. So d by dx of sine x. So as we have discussed it previously, d by dx of x cube is 3x square. Similarly, we can say if we replace x with some other variable, let's say t, and we have to calculate d by dt of t cube, then again it would have been 3t square. So on the similar grounds, we can say d by dx of sine x whole cube when the input parameter is sine x is 3 sine square x, or we can say 3 sine x whole square, both are the same thing, multiplied by the differentiation of sine x with respect to x. So as we have seen previously, d by dx of sine x is cos x. So the final result for this composite function is coming as 3 sine square x cos x, right? So now let's take another example on chain rule. So let's say y is equal to 1 plus x square whole square. And we need to find dy by dx for this. Since this is also a composite function where the inner function g of x, when this whole is f of g of x, then the gx, the inner function, will be 1 plus x square, and fx will be x square. So if we plug in gx inside this fx, so if we replace x with the value of g of x, then this will be g of x whole square, and that will come out as 1 plus x square whole square, right? So this is the inner function, and this is the outer function. So now let's apply the chain rule. So dy by dx will be the differentiation of this composite function, that is 1 plus x square whole square with respect to the inner function, that is 1 plus x square, multiplied by the differentiation of the inner function, which is 1 plus x square, with respect to the parameter of the inner function, that is x. So this is the chain rule. Now, as we know, differentiation of x square with respect to x is 2x. So if we replace 1 plus x square with t also, then differentiation of t square with respect to t will again be 2t. So on the similar grounds, differentiation of 1 plus x square whole square with respect to 1 plus x square is 2 times 1 plus x square. Okay. And now we find the differentiation of the second part. So the differentiation of 1 will be 0, and differentiation of x square with respect to x will be 2x. So this will be 2 times 1 plus x square times 2x, which would be 4 times 1 plus x square. So this is the differentiation of this composite function, as we found out by the help of chain rule. So now let's take one more example on this chain rule. So let's take an example now which is a little complicated. So now our next example is, let's say y is equal to x ln x plus 3 whole squared, and this thing is whole squared, where ln x is log base ex, and we need to find the dy by dx in this example. Since this is also a composite function, so we will first find the inner function. So the inner function g of x will be this part, that is x ln x plus 3, and the outer function f of x is, if we fit this thing in x square, then we get our main function, that is f of g of x. So the outer function f of x will be equal to x square. And hence we can, we verify this by replacing x with gx in f of x. So then we get g of x whole square. So this will be g of x whole square. So this will be x ln x plus 3 whole square, which is same as our main composite function, which verifies that our assumption for inner function and outer function both are correct. So every time we plug in gx inside fx, we can easily verify our composite function like this. Okay. So as we have defined our inner function and the outer function, now we can easily apply chain rule. So dy by dx will be the differentiation of the composite function, that is x ln x plus 3 whole square, with respect to the inner function, which is x ln x plus 3, multiplied by the differentiation of the inner function with respect to the function on which it is defined, or we can say which is with respect to the parameter, that is x. So now, as from our previous examples, we know that d by dx of x square, differentiation of x square with respect to x, is 2x. So similarly, the differentiation of this will be 2 times x ln x plus 3. Multiplied by the differentiation of x ln x plus 3 with respect to x. Now this x ln x plus 3, this can be written as our first part times differentiation. Differentiation of 3 is 0 plus d by dx of x ln x. So we are breaking by the algebra of derivatives. So what remains is 2 times x ln x plus 3 multiplied by d by dx of x ln x. Now we need to calculate d by dx of x ln x. Okay, so let's write it. So this will be 2 times x ln x plus 3, and the second term d by dx of x ln x. So we can use the product rule here to compute the d by dx of x ln x. It states that first function multiplied by differentiation of second function. I guess I have written d by dx before the whole thing. Yeah, I have written d by dx before, so let's just rewrite our result till now. So here, first function times differentiation of second function plus second function multiplied by differentiation of x, that will be 1. So this gets cancelled, and our answer will be 2 times x ln x plus 3 1 plus ln x. So the final result for the question is this. So this was another example of chain rule. So this was it for this video. Do join me in the next video where we see more examples. Bye bye.